Well, hello everyone, and welcome to our presentation on driving operational efficiency through cloud optimization. This presentation is brought to you by DS. We're a technology consulting company based out of Melbourne and Sydney, and we specialise in emerging technology to solve difficult problems, get new ideas to market, disrupt traditional business models, and unsurprisingly, we use the cloud quite a bit. My name is Matt Fellows. I'm a principal consultant here at DS, and I specialise in the cloud, architecture, and our DevOps practice. Just a quick note to let you know that we'll be taking questions live throughout the session, as well as at the end of the session, so do please stick around. We'd love to chat and engage with you a bit more deeply. In today's session, we're going to discuss the importance of investing in your cloud platform. As a result of COVID-19, a lot of companies are looking at how they can get the most out of their technology investments, particularly in the cloud, and in particular how to keep those costs down. So amongst the broader optimization topic, we did want to make that a particular focus in today's session. And we're going to start by taking you through some of the lenses in which we, approach cloud and other initiatives, and some of the architectural principles that are common to any cloud implementation. We're then going to zoom a bit more into the cost optimization aspect. We're going to start by looking at the total cost of optimization, or TCO. We're going to do that through the lens of an example initiative, just to illuminate how you can look at investments in new cloud initiatives, as well as historically reviewing existing investments. From here, we're going to look into some fundamental hygiene aspects to really underpin any efforts to operate effectively at scale. And then we'll finish by drilling into some more detailed techniques to reduce your bill right now. The techniques we're going to talk about today largely going to be a bit more technical in nature, not because they're more important, but we do find a lot of customers just don't realize that there are other tools and approaches to reduce their cost, and then how accessible they are. So for example, there's a lot of talk about reserved, committed instances, things like savings plans. We're not going to cover those today, not because they're not important, but they're very well covered elsewhere. So let's get started. Okay, so let's start with the cloud architecture and how we approach that. So as with any project at DS, we always start with the customer. It's important to understand the various differences the customer has and tailor any solution to those needs. So for example, we can often perform a sliders exercise with clients just to explicitly call out and rank various trade-offs. And that really helps get the team set from the beginning. So for example, you might be familiar with the iron triangle of project management: time, cost, and scope. The sliders is a bit like this, but you're explicitly getting to call out what's more important relative to other items. So for example, here, we've obviously got the three things we just talked about, but then there's architecture within that. So is performance important? Is security more important? Perhaps the scope is more important. And we can trade these things off in the context of the broader company context. So things like, are you a startup, or are you a scale-up or an enterprise? You're probably going to have different needs and motivations. So for example, startups tend to need to move a bit quicker to get revenue to keep them going. Enterprises tend to be more conservative and have risk-averse perspective, and also just need to keep things more stable because they've got more customers. Then there's the cloud maturity. So how well supported will this solution be at the end by the team internally? Is a really strong cloud team available to nurture and maintain the platform, or is it sort of a nascent capability that we're still needing to nurture? And that might just change how we build and how complex the solution is. Then what is the life of the product? Is it an experiment? Is it an innovation piece? Is it a strategic asset? We look at things like the security profile and the risk appetite of the company. Again, financial institutions, regulated industries, they tend to have a different risk appetite relative to others. Then of course we actually look at the project itself and look at the different needs and requirements of those projects. So with that in mind, once we've got that context set, we then can look into the solution and the architecture that underpins that solution. So we're pretty lucky. Most cloud providers have pretty good guidelines on best practices for using the cloud and principles in terms of designing for cloud-first architectures. So in the case of Amazon, they have the well-architected framework. As you can see here, there's the 5 pillars, and we'll talk through those briefly just now. So the first one is operational excellence. So using tools, practices to ensure the system is continuously delivering business value, and there are ways to continually improve the operational excellence and improve processes. That's going to be one of our focuses for today. And then of course we need to care about security, so things like protecting data, reducing risks, and making sure you're mitigating those risks. Reliability, so ensuring the system is able to scale up, but also scale down on demand and navigate unanticipated system disruptions. And then performance, so ensuring resources are most appropriately used by the system. So this often involves right sizing, making sure that you haven't got more or less capacity than required, and that the systems perform efficiently with those resources. And lastly, again, going to be a focus today, is optimizing the ratio of business value to cost. So we want to get the most out of our cloud platform for the least amount of money, hopefully. And of course, all those principles, there's a huge interplay between them. But thinking about all these various pillars allows us to build an architecture that's flexible, that scales up and down, and really moves with the customer's needs. So once we've sort of thought through that solution, we've put those architectural principles into the solution, we then can look at things like the total cost of ownership. So we want to make sure that any proposed solution has a strong positive return on investment attached to it. So we can do a total cost of ownership analysis to view the predicted performance of a new investment, but also look historically at existing investments, just to make sure that what we have done is still appropriate moving forward. I think one of the things about the cloud today that we can often forget is that they are all investing so heavily and reinventing and disrupting themselves. So just think of when Lambda came out that disrupted EC2. So doing nothing can often mean missing out on drastic performance gains or improvements in cost or efficiency or any of those pillars we just talked about. So it's often a good exercise to try and do, whether you've got a new project coming up or you want to look at an existing asset. So let's look at that now. Okay. So we kind of talked about it, but it's easy to look at the end of the month and wonder why your bill costs what it does. And sometimes it's easy to forget the kind of value you're getting from the overall solution. So we're going to look at some of the factors at play here with a bit of an example. And the hypothetical example we're going to go through is pitching yourself as part of a team that needs to get a new product to market. So the scenario is this. As a result of COVID-19, there's been an increase in demand for our signature fidget spinner product, and there's an opportunity to create a digital version of it. Our innovation team has created this web-based product that allows school-age children to distract each other during recess, and that addresses a key pain point for parents who are working from home. So our goal is to compare two proposals that the team have put together to release this new app to market. One is to build their internal platform, which is going to have their own customer requirements around it and a team to build it. Another one is to use a platform as a service, so something like Beanstalk or Heroku, to release this new app to market quickly. And we're going to compare the total cost analysis of both of these things. So to keep the scenario simple, we're not going to be looking at all the complicated accounting measures, things like amortization, capitalization, and so on. So we're going to try and keep that simple. If we look at our assumptions here that we're going to bake into this model, the first thing is the cost of delay. So what we mean by this is that each week we haven't got our product to market, how much is that going to cost us? So in our case, we're hypothetically going to say we're going to lose $5,000 in revenue per week that we're not in market. We're going to assume that the labor cost of people is going to be $1,000 per day. That makes the maths a little bit easier. And we're going to assume a 5% monthly growth in usage over time. And we're going to model that investment over 3 years. So let's look at how these inputs have affected the total cost of ownership over time. So hypothetically, our internal platform takes 8 weeks to build, and it takes 2 people to build that. So it also requires 2 days a month of maintenance and upkeep from the development team. So things like tuning the platform, making sure the tools are still working, responding to issues, bug fixes, and so on. And our monthly bill is about $500. Compare that to a platform as a service offering. It takes 1 week for 2 people to get the platform up and going. And it takes about half a day a month to maintain that platform because we're really offsetting that effort to the cloud provider. And we're going to assume the bill is 3 times bigger per month. So it's $1,500 per month. And we're going to assume further that it's a 5% monthly growth in usage, and that's going to increase the cost as we go. So if you model that out through a bunch of graphs, this is kind of what it's going to look like. And as you can see, the total cost of ownership for an in-house platform build is far more expensive than a PaaS, even though the monthly running costs are significantly higher. And you can sort of see the factors at play here. The main issue is that the initial cost of the build is very high, and the cost of delay is also quite significant upfront and accounts for most of the difference. And then even the monthly ongoing cost, even though the cloud provider itself is charging a bit more for the PaaS, the maintenance and upkeep is just much higher for the internal platform. So the key takeaway here is not that one is better than the other, but that there's a big trade-off in investing in creating your own platforms versus using platform as a service tools. So larger organizations with many teams and products can probably get more and gain more from this efficiency relative to the costs, simply because there are more people and more teams. And that is generally also true for smaller organizations. But the point is you can use this sort of analysis to forward project the costs of existing for new projects, but also look back at existing projects to see if they're still worth investing in or if it's worth pivoting to a different solution. Okay. So with this background in mind, we're going to look at approaches in gaining control of your cloud environment and then drill into a couple of concrete cost reduction steps you can take right now. So historically, when embarking on a cloud journey, the task of organizing various accounts, providing access control for teams and systems, creating guardrails, all these things were left up to the companies themselves. And this was a pretty time-consuming and costly task, and generally required a number of people to keep that solution going. But as cloud platforms have matured and best practices have started to emerge, cloud providers have started to bring together pre-built solutions that give you a leg up so that you can be productive quickly, whilst not compromising on security, governance, and all those things. And these things are often called landing zones. So landing zones give you this centralized macro level view of the world, while not compromising the flexibility and agility that makes the cloud such a great choice for so many projects. It really is a first step in gaining control of your cloud operations. So as I said, many customers spend months building their own homegrown version of landing zone, which really does come at a high cost of maintenance, and it's not transportable. You can't bring people off the street who know your cloud environment. They have to learn that, and that takes time. It's very expensive. So for example, at a major Australian university, we rolled out a landing zone solution to get them started on their cloud journey. Within a 2-week sprint, that was done, and we're already looking to integrate with their SSO and other systems internally. Within just a few months, they launched their first chatbot, and within 6 months, their initial IoT platform. So it just kind of goes to show you how fast you can get moving with this and the kinds of benefits you get. And I should mention that team has had, and maybe still doesn't have, any team dedicated to keeping that alive. So the next thing to look at is, whilst landing zones give you a macro level view of your cloud environment, they don't really provide the micro level detail you need to operate efficiently and securely at scale. So this is where tagging comes in, and really is one of the most fundamental steps in getting the cloud to work for you. So things like cost reporting, governance, security, and automation are often built on the back of good tagging strategies. And because there are so many use cases for it, it's really hard to understate the importance of doing this well. And all cloud providers have a way of tagging or labeling their resources, but without tags, it's actually really hard to link costs back to initiative in particular. So despite sounding quite simple, a lot of customers don't do it or don't do it effectively, and they miss out on a lot of the benefits of doing it. And because only you know what systems are running in your environment, really the onus is on you to ensure the resources are tagged appropriately. Unfortunately, other people can't do it for you. So some of the use cases that we'll talk about are really, for example, identifying what resources make up a particular application, identifying the owners of resources for an account, so for things like cost allocations or maintenance notifications, for classifying workloads, so is it PII data, is it public data, is it something else, is it mission critical? We can also denote which environments are non-critical for cost savings, which we'll talk about shortly. And then of course, just to enable all kinds of other automation. So tagging can be complex, and they can get complex quickly, and can be a bit harder to apply after the fact rather than upfront. Now we'll talk about some strategies later to improve that, but a really good starting point for tag is just getting them added to the most cost-intensive workloads. So things around compute or database or AI and cognitive services, they can be a bit pricey. So get tags on those first. That gives you quick visibility where you can dive into the costs and actually see what's going on. Okay, so now that we have a hand on these basic hygiene practices, let's go a little bit deeper and talk about some of the cost-saving techniques. So the lowest hanging fruit here is simply shutting down environments when they're not needed. Most organizations run multiple non-production accounts, and in many cases this accounts for the greater portion of your cloud bill. So generally speaking, these environments aren't required on weekends or night times, So if you just shut them down, it just means you stop paying for them. And obviously that's going to mean you're going to save some money. So I know at least one customer who reduced their bill by literally over $100,000 per month just by doing this. So how do we do it? Well, the first things first, unsurprisingly, is we tag it. And we denote which resources and which compute capabilities we don't need during which periods potentially. And we mark them eligible to be shut down. And we can use schedules or on-demand shutdowns to do this. But other approaches are to start up environments at the start of each day, and then shut them down at 6 or 7 o'clock at night, whichever makes sense for your team. For example, in Packflow, which is one of the products of DS, we use Slack or Slack Ops to do this. So we have a bot that sort of reminds us each morning if a test environment should be started, and if it's scheduled to be shut down each night. And then we use Slack commands to manage this, so we can pull it up on demand if we need to, or shut it down on demand. So that's just a nice little way of doing it. An example customer that uses this is NIB. We helped create their infamous Red Queen platform a few years ago that runs on Amazon. They created a tool called Hammer Time, which is focused on compute and databases in particular. And they're traditionally the most expensive parts of your bill. So they've used this to great effect and have actually open sourced their solution on GitHub. So we'll provide a link in the slide deck afterwards. So if you run any kind of standardized environments for specific workloads, so for example, if you're running Kubernetes for your microservices or have a standard microservice template, applying shutdown rules in that template is usually something you can do within a week or two, and then you can push it out to any teams using it, and then you can immediately get to some values in shutting down environments. Of course, there are a few challenges. You do need to be conscious of how you're going to impact the development team when you do this. Obviously, saving a few dollars on your cloud bill could just be offset by the unproductive developers. So something you need to consider there. It optimizes fairly broadly. It obviously, it's just going to shut an environment down. It's not going to make sure the environment is actually using the right resources, the right size resources, is it an appropriate architecture, these kinds of things. It's really just going to brute force turn them down. So it doesn't get you that really detailed cost reduction. Things like load balancing groups and auto scaling groups, you just need to be careful if you're shutting an instance down but not taking into account the auto scaling rules. The system might be designed to be resilient and just start back up those services. And lastly, you probably do need to think about, especially if you're a global company, what time zones the servers are in and what time zones your people are working in, and just be conscious that shutting them down in the wrong time zone means that things aren't going to work. Okay, so the next trick up our sleeve is the use of spot instances. So cloud providers have a large capacity of unused servers that are able to be used at a fraction of the cost of their listed price. And so typically that can be 80 or 90% cheaper than the market rate. And the reason they're so cheap, so what's the catch? Well, because they're taking from this unused capacity, this pool of unused capacity, and they're just sort of sold at the sort of lower market rate, at some point they may be required to be brought back into the general pool. And when that happens, the instance may be shut down at a short notice. The different cloud providers have different approaches for this, but largely speaking, that's what happens. And so you need to treat them as much more ephemeral in nature. And so we'll talk about how we can deal with that in just a moment. But there's a few good use cases for these kinds of things. So for example, if you've got non-critical workloads, again, like dev environments, that's a good place to start because, again, the non-critical, if there's a small blip in availability whilst a machine gets sorted back up, it's usually not a big deal for your development teams. But of course, there are some really good use cases for spot instances that can work in production environments. So things like batch processing or ad hoc processing, reporting, offline workloads, anything where a customer is not going to be directly impacted by the server being removed from the system at short notice is a really good candidate for spot instances. And as I said before, you can really save such a huge amount of money that for anything asynchronous, it's a really good option to start considering. Of course, if you're wanting to run this in production for other customer critical workloads, rolling out a more advanced spot instance program can take a little bit longer, and you need to consider a lot more resilience designs into your architecture. But to get it going in a dev environment often can just be a few lines of configuration, and your stack will just relaunch using cheaper instances. So it's usually something you can do in just a couple of days. Okay, so the fifth thing we want to talk about today is, and the third cost reduction measure, is just literally terminating resources that don't conform to your tagging or other policies. And there's a bunch of good reasons for this. So as you can see here, there's a notification where an instance was just shut down because it didn't conform to a tag, and a notification was sent through Slack to us. The reason why it's good is that it really just underpins and enforces good cloud hygiene. So once you've got your tags in place and your policies in place, you can now use strategies like this to ensure that you're now keeping that good hygiene up. It also really helps with compliance and governance efforts. If you know what your resources are and they're properly tagged, you can always report internally or externally that your systems are complying with the standards you set them. But also prevents accidental costs. It's really easy to spin up a server somewhere, not tag it, and then forget about it. And then when someone wants to go and do a cleanup exercise later, because it's not tagged, it's very hard to work out if this is actually a customer-facing thing, if it's critical, if it's needed. And so it might just get left there because you're not sure what to do with it, and that's just cost that you're leaving on the table. So how would we do this? We normally do it with tagging, as unsurprisingly, and we set configuration policies. Again, the different cloud providers have different ways of allowing you to set a policy and enforce that policy, and we typically use automation to do it. In fact, it's very hard to do it without automation. The challenges, of course, are production. You'd be very careful about doing this in production. And so obviously would suggest starting this in a non-production environment. And then, communicating with teams, so how they know to tag things properly, what's going to happen if they don't tag it properly, potentially sending them a notification to say that the server has been either shut down or taken out of the pool or terminated. These are strategies you can use to communicate more effectively to teams. Okay. So we talked a bit about some cost reduction measures. We talked about some good cloud hygiene. The last thing we want to briefly talk about is automating with infrastructure as code. And so DevOps practices such as CI, continuous integration, automated test, infrastructure as code, they all enable the previous technologies, techniques, and strategies we just talked about. So without automation and infrastructure as code, it's kind of hard to apply all those policies and controls and cost techniques really effectively and reliably. Automation is really going to increase the success of everything we just talked about. So the benefits in using infrastructure as code are really going to come down to the following things. You're going to be much safer and faster and more consistent. So faster because obviously the more and more resources you have in your cloud environment and the more cloud environments you have, that's going to take a lot longer to do manually. So if you can just run an automation piece over that, you're going to be able to apply changes to thousands and thousands of resources in minutes. Obviously safety. Humans will make errors, they'll forget things, will miss something, or will make a mistake. Computers, largely speaking, once you've told them what to do, are going to do it pretty well. So that means it's going to be much more consistent and much less likely to roll out a problem. So really helpful if you have a large multi-cloud environment. There's a maturity model here that goes from working through the console or clicking through the console, we call ClickOps. And then from there you might go, okay, let's try and automate some of the basic tasks. So you might use CLI or API calls to do that. You'll then move that into a script that you can rerun over time and use tools like we mentioned over there. So things like CloudFormation, Terraform, then there's configuration management tools like Ansible, Puppet or Chef. There's really a lot of tools in this space and a lot of free tools in this space that you can take advantage of that will start to run those scripts automatically for you, get that into source control, then run it in a pipeline. And once you've got that running through your continuous integration pipeline, you're really set to take the most advantage out of your cloud. And what you can do is get more and more sophisticated. You can just add more and more rules, more and more capabilities, and it's just going to run for itself. So if you get this right, automation will be the most important thing you do. Okay, so let's recap. So we talked a bit about cloud architecture and how we approach projects, as well as the best practices in the cloud. And obviously this is all contextual. Everyone's going to be different. Once we sort of get the context and those architecture principles in place, we then need to think about, well, what is our total cost of ownership and how can we review and continually evaluate the reliability, the performance, and the cost efficiency of those solutions. We talked about 2 hygiene practices. We talked about landing zones and creating a space to manage your macro level view of your cloud environment. And then we talked about tagging, which is a way of getting a micro level view down to the cost allocation reporting. Once you've got those things in place, we can put in some cost reduction techniques pretty quickly. So things like shutting down our dev environments when they're not in use, using spot instances to get a much cheaper market rate on compute, and then just terminating any resources that aren't conforming to your standards. And then we talked about how we can use things like automation and DevOps practices to continually evaluate and improve all the things we just talked about. Okay, well that's it for our talk for today. Thank you so much for coming along and listening. We hope you learned something today. As I mentioned earlier, we will be taking questions after the talk still, so please do hang around and we'd love to field your questions. And also afterwards, please join our DS Community Slack channel where you can meet the team and you can ask questions about cloud optimization or anything else that we do. You can join us at ds.tech/Slack. And of course, you can get to our website at ds.com.au and you'll be able to find all of our other channels there. Again, thanks for coming along, and we hope to talk to you soon.